This video is going to be how to capture data for a time series using the eIQ NXP tool. This is the Eval board of the MCXN947 device with the shield on there that's got the couple motors. One is a lopsided motor and the other one is just a plain motor, but it's got an accelerometer on it as well, and we'll be using that today to capture time series information and run it through the modeling tool to do some classifications on vibrations of a particular monitoring environment. Let's say if you have that attached to a motor or some bearing and want to determine if it's going bad. So anyway, this is the hardware we're going to be using to do this. Let's pull up this COM port real quick. So in our last video, we were going through the time series canned anomaly detection project, and so the end result is if we have the binary programmed into our target and open up a COM port, we can get to this help screen here. It's got a shell that's running, and so we can say like get info, and it shows which eval board is connected up, and then it shows the sensor and shows some of the other specifications for the capture of the data. So that's good information there. And once we have our shell details, consult the other video that I have in the description of this video I'm doing right now to be able to get this shell programmed into the target. So once you have the shell, you can say start log, whoops, and it will show you the data coming from this accelerometer sensor. And as you move this thing around, you might notice some of the patterns change. So I said start log there, start space log. Now I'm going to say stop. Okay, so I've got the logging in the stop position. Now what I'm going to do is I'm going to come over to the eIQ tool. I believe you got to be logged into the portal over here. Up on the top left it says eIQ portal. So once you get logged in there, you can hit the time series. And it brings up this time series studio. Right now I'm not going to upgrade the software. I'm just going to use the version that I have on my computer. Let's see, that should, okay, so it comes up and it says, do you want to download the new one? At this point I'm not going to do that. I'm working off of what is it, yeah, I'm not sure what version I'm using, but anyway, I'm just going to cancel that download out, and it brings up this home screen here. I'll hit the home button. Within that environment, you can come over here and click on the data logging over here. So hit data logging, and step number 1 is program time series studio firmware. I'm going to hit continue, and then what I'm going to do is I'm going to come over here and go to COM port 12. And when I was over on the Terraterm over here, I'm using COM port 12. I may have to shut this one down. I'm not really sure, but I will close it out just to be 100% sure. So I'm on COM port 12. If I hit refresh, there's the COM port 12. Put it on 115200 baud rate. From there, you can hit the connect button. And then at this point, what we're going to do is we're going to have the data rate on the frequency over in this section to 800. Let me just confirm that. So I'm going to select that over here on 800. I'm going to do the accelerometer G rate of 2. Window size is going to be 128. And then we've got X, Y, and Z on the sensor. So that looks good. So then what we're going to do is choose the sensor and the parameters, and then we're going to click continue here. At this point, we're going to define, we have 3 channels up there, and we're going to classify only 2 states for this model. So 3 channels of sensor data and then 2 channels of classification. It's either going to be a good vibration sort of environment or a faulty one. And then once we get to that point, then we'll hit this checkbox, and then we need to type in a file name for the classification here. So what I'm going to do is I'm going to type in normal_train. Normal_train. Okay. And then we're going to have that being class number 1. And we're going to capture for the normal situation for training the model 100 lines. And then what we'll do is we're going to hit the start button, and you can see the 3 different channels here and what the data looks like on the sensor. Right now the eval board's just sitting flat on a flat surface, and there is no vibrations, major disruptions of the data. So we're going to capture that information, and it's ticking up to 100. What we're going to do is once we get to 100, then down here we can open up the saved data set. So if we click that, it's got a long path up here, but here's the data set right there. We'll just open that up and see what's in there. So that's what the log data looks like. So it's 100 rows of or samples of the XYZ. So we'll close that back down, come back over here. So now we just created this normal train, and then in the world of testing models, we need to have some other information or data sets to do some testing against the normal train model. So what we're going to do is we're going to make another file called test, and these data sets could be independent of from how you capture the normal train file. But we don't need to capture as many lines because we're testing the model, so we'll have a reduced number of data sets. So we'll do 50 here, and then at this point we still want to classify class number 1 for the normal case. So we'll hit start here, and it's going to go to normal test. So we'll hit the start button, and we'll collect our I guess, did that collect the 50 already? I guess it did. And we can open that one up, that file. Here's our normal test. We can see the file's much shorter, so we'll close that down and come back over here. Now what we're going to do is we're going to, let's see here. What do we got to do now? guess we're gonna hit this. I believe we hit the stop button now. We've got those two files. Now we're going to go and focus on the abnormal class number 2. So what do we want to call that? Abnormal train underscore train. Okay. So you got the abnormal underscore train. It's going to be the second classification because there's going to be some vibrations injected on the accelerometer. So what we're going to do, because this is the train, we're going to expand the number of data sets. So we're going to increase it up to 100. And then when we hit the start button, what I'm going to do is I'm going to just start tapping on the accelerometer, and then you should see it show up over here that it's going to be having disruptions. And so we're training this new file for classification number 2 with some disruptions on it. So let's hit the start button, and as you can see, the sensor is putting some abnormal data and being captured into the lines, the 100 lines. So we'll continue to do that until we reach line count of 100. Okay, so we've reached that, and if we open up the save data set, we can see we've got abnormal train. Now we've got to do abnormal test. So at this point, I believe we're going to be coming over here, leaving on class 2. We can put 50 in there, and then change the train to test. Let me just confirm that's the correct parameters. All right, so once again, I'm going to be tapping on the accelerometer because this is an abnormal vibration, and here you can see we're getting some impacts there. So I'll start to tap. Okay, so we're going to count up to 50 lines with these abnormal tests. So just random impacts on the accelerometer. Okay, so now we capture those 50. If we open that up, at this point now we have 4 files we just generated. We got the normal files, which are class 1, and then we've got the abnormal, which are class 2. Okay, so at this point, we've got all that captured. So the next thing we're going to do is we're going to come over here and we're going to look at this data operation over here. So we go to data operation, and we want to import some files here. So now I've got to go to the path where those files are at. So I just got to navigate. Let's see, over here, app data, roaming, time series, studio, data logging, and then let's see here. It's this guy right there. Okay, so now these are the files I just got done generating, and I believe I can just select all of these at the same time. So we'll use the shift key, select them all, and hit open. Oop, I guess that didn't work too well. Let me try that again. Maybe we'll do one at a time. Import. Okay, did I get it all? Let's see, abnormal test. Let me import some more. Let's do some normal files. Oop, let me hit the pause button for a second. Okay, so I'm going back and generating a normal underscore test2 file with 100 lines in it in a class 1. For some reason, that one file was corrupted or didn't capture correctly. So let's see if this test2 file can be brought in easier now. Okay, so let's open up the data set. Okay, so there's a test2 file in there now. Okay. All right, so let's go back over here to the data operations and see if we can import the test2. Okay, great. Okay, we got the test2 in there. If I try to import just the normal underscore test, which is right here, for whatever reason, it's got some issues with that. And I did open up the Excel file. I don't know if when it saved. Oh, let's see. This is the normal train. Maybe it's in there. Okay. Well, let's disconnect this test2. Okay, so we got the normal train, abnormal train, and the abnormal test. Let's see. So, oh yeah, I do need. Maybe I do need that one. Let's see. Yeah, so if I do normal tests, that's going to bomb out. Okay. All right, so we're going to import the normal underscore. I guess that's going to have to be, yeah. I should be doing train there. Let me pause this again. Okay, yeah, so it is the normal underscore test is actually in this one. I could probably just delete this guy since it didn't work out too well. And I'll go abnormal underscore test2. Okay, so now I've got 2 abnormal files and I've got 2 normal files. And so that's the data that I just brought in. Okay, so now what we're going to do is uncheck this, ignore the first label line on these files. And then at this point, we're going to go over here to wash the data, remove lines that have no 384 columns or contains blanks and stuff. So we'll run that. Okay, so at this point, we have all these clean files, and then we're going to hit save all, and it's going to save it to a zip file. Okay, so if you hit the save all, it's going to save the zip file. I just stored it under C:(TSS blank or space example. So here's the zip file. I don't know if I can expand. Yeah, I'm going to expand all those files. So here is now the washed, the WD is washed datas, and so here you go. Got a bunch of data here. I was just looking at the file sizes here. It's interesting that this one is a little smaller than some of the other ones. Not sure why that is. I guess that looks somewhat normal. Now we have to come back. So we're going to come back over here. And now we're going to, so basically we captured the data, we washed the data, and then we saved the data in a zip file and then expanded it out. Now what we're going to do is come over here to the anomaly detection, and then we're going to create a new project, and then what do we want to call it? Here, let's pause this for a sec. Okay, so we're going to call this one anomaly underscore detection underscore with underscores and then 2 classes. So from there we have to select the Eval board that we're using, which is the N947, which is right here. And then we've got a 3-axis accelerometer, so we're going to have 3 there. The library max RAM size is 512 kilobytes, and then the flash size max is 2 megabytes. So at that point we have the we're going to hit what, confirm and create, I believe. Okay, now we're going to come over here and we're going to put we've got the normal state 1 and the abnormal state 2. Okay, so next what we're going to do is we're going to define the normal training data set. So we're going to hit the plus, and this is where the files were expanded from the zip file. So we're going to do the wash data normal train. So we'll select that one, and we'll click this box up here, which gets all the rows included, and then we're going to hit load. Okay, so now down here we can see we have normal 100% overall sample distribution, and it did collect or check the normal button up here. So that looks good. So let's see here. Let's hit the pause button real quick. Okay, let's go ahead. We've got the normal file loaded. Now we're going to hit the plus, and we're going to do the wash data abnormal train file. We'll click this top row here, and it selects all the lines. We're going to hit load, and at this point we've got the checkbox on the abnormal and the data file associated with that one versus the normal in the data file. And as you can see, the overall sample distribution is 50-50. So that is looking interesting there. So once we get to this point, let's see what we have to do next. Okay, so we have our data sets for the 2 classes. Next, what we're going to, so we did the create a project. We pulled in the data sets. Now we're going to do the training. And so we got all the information loaded. So we're going to hit start training. And we're going to do the train val ratio of 8:2. Let's see what else we're going to do on a quick search, and then we're going to hit the start button, and then it's going to start doing some number crunching, and then as this continues on, we can see the timer up here tick away, and then the percentage of going through, searching through the data sets and looking at these various top 12 models over here on the left hand side. So let's let that continue on. Over here on this side you can see the benchmarks and how much flash and RAM is required with some of the accuracies that you would be getting depending on which model, fitting model that you're going to be potentially using for the project. So right now we're at 60%. We'll let that run through, and then we'll see what's going on after that point. Okay, now we're at 100%. What I'm going to do is click on this number, model 24. You can hit this report button and kind of see what's going on with it. And there's a PDF that you can save if you want to. And then the confusion metrics, let's do percentage. So that's some information that's useful for better understanding how this model is going to work for your needs. Okay, so once we have the model trained and we think we have a model we like, we're going to come over to the next tab, which is the emulation tab. And I'll check model 24. And then we're going to make a new emulation. And at this point, we can select the various training files. Okay, so this one's the normal. So I'm going to do, we're going to select the test files, pardon me. Okay, so here we got that test file. And here's a test file right here for the abnormal. Okay, so we got the normal state and abnormal. Okay, so we got that in there. And then, so we got the testing files loaded up here. Then we're going to hit the start button. And the testing data is going to check the training data for accuracy. And we'll see how good the model's working. Okay, so this is running. Let's see, is it done running? Okay, here. Okay, so as you can see, there's the accuracy is 93% on, what is it? I guess that's the balance accuracy. Okay, so if you wanted to get improvements on your accuracy, I think you'd have to do more data sets to enhance the accuracies. You can also pick some of these other models over here if you would like to include those, but as you do that, your RAM usage and stuff will be changed. Let's see, does it have the information there? All right, so that's what we got with this emulation. And then, you know, once that is complete, we can deploy that. So let's hit deployment button. All right, so we come over here and we can create the project and just make sure we got clicked on GCC. So I think that should be good, and then just hit the generate. And then there's your new project file that you can import into the MCU Espresso environment. We did this import example in the previous video that you can look at. That will be listed in the description of this video. So consult that video for loading your project into MCU Espresso. Also, when you import the project, you have to make a couple lines of modifications, and you gotta uncomment and then comment out some couple lines, which are talked about in that other video. Anyway, hopefully you like this overview. This could be helpful for your time series needs for your applications. Please like, share, and subscribe. Thank you.